In the previous video, we talked about the first formula to find the equation of a straight line, which is called point-slope form. And the reason is, in this form, the number in front of parentheses is the slope. And these two numbers, x0 and y0, is a given point. That's why we call it point-slope form. And as in this example, we have y minus 3 equals negative 4 times x plus 2. This is the format of point-slope form. But we can also do some algebraic work to get rid of parentheses by distributing and to move the negative 3 to the right to get y by itself. And this last form is equivalent to the point-slope form, but it's just in a different format. So I mentioned that this is called a slope-intercept form. And here first we're going to explain why this is called a slope-intercept form. Let's look at the equation y equals negative 4x plus 5. As you remember, the number negative 4 is the slope given, negative 4. And the negative 4 stays in front of x because when we distribute negative 4 into the parentheses, and the number in front of x in the parentheses is 1. So when you distribute negative 4 to x, you always get negative 4x. So the number in front of x, although the parentheses are gone, the number in front of x will still be the slope. So first of all, this number right here will still be slope. And that's easy to see. That's our slope. But why this number is called an intercept? And again, the reason we call this the slope-intercept form is because the number in front of x is the slope, and the other number is the constant number without x is the intercept. So we can explain that. Remember that to sketch a graph, we can make a table, pick numbers for x or pick numbers for y. So if I pick 0 for x, replace this x with 0. Negative 4 times 0 is 0. 0 plus 5 is 5. We're going to get y equals 5. And similarly, we can pick a number for y. Let's say pick 0 for y. If we pick 0 for y, we're going to get 0 equals negative 4x plus 5. And we can move negative 5 to the left by subtracting 5 from both sides. And we get negative 5 equals negative 4x. And we divide both sides by negative 4 to get x by itself. And negative divided by negative is positive. So we got x equals 5/4. X equals 5/4. Okay, now we are ready to sketch the graph. And notice that we got two pairs of solutions. One of them is 0, 5, which means x equals 0, y equals 5. 1, 2, 3, 4, 5. On the y-axis, that's the point is 0, 5. And when we pick the other pair of solution is 5/4, that's x. The first number is always x, the second number is always y. So 4/5 is 1 1/4, so it's probably somewhere right here. And y coordinate is 0. This point is 5/4, 0. Now we join these two points and we can get a straight line. Okay, so oops. So we are joining these 2 points. Again, my line is a little bad. And so this line that goes through these 2 points, we found 2 solutions. Geometrically, it's 2 points, but algebraically, they are solutions of this equation, algebraic equation. And we join them, we get a line which represents infinite many points. Also, there are geometrically, but algebraically, these infinite many points correspond to infinite many solutions of this algebraic equation. So let's take a look at the number 5 here. Number 5, as you can see, is exactly the point, the y coordinate of the point that intersection point of the line and the y-axis. So that's why we call it y-intercept. So this point is the number 5 is our y-intercept. So that's although we just call it a slope-intercept form, this 5 here is actually the y-intercept. All right, so we have another format. In general, it looks like this. Of course, we still have two variables x and y in there, but the number in front of x is the slope. Let's use the variable, the letter m to represent that, times x plus the other number. We can use b to represent it, to represent the intercept. So this form is our second formula. It's called slope-intercept form. And remember, the number in front of x is our slope, and the other number is our y-intercept. So suppose we're given m equals, given m the slope 2/5 and b y-intercept is 3, and we want to find the equation of the line with this steepness and intersects y-axis at 3. So by plugging the numbers, so m, as long as we know the formula, all you have to do is to plug in numbers. So we have y equals, replacing m with 2/5 times x plus b is 3. So that's the equation called slope-intercept form. And similarly, for the second example, we replace m with -2 and b -5. And so this, because it's actually plus -5, but the plus sign can be omitted. So these two forms are called slope-intercept form. Now we also have, so this is our second formula. There are also other formulas, but the other formulas can basically be generated by either slope-intercept form or point-slope form. Let's summarize these two formulas here. So the first formula we learned is point-slope form. Y minus y0 equals m times x minus x0. And the second formula is slope-intercept form. Y equals mx plus b. And next, we also have a formula called a 2.4, but as long as you memorize these two formulas, you should be able to use them to generate the other formulas, so you don't have to memorize a lot of formulas. And in calculus, the first formula is preferred. And but in algebra, maybe a lot of times we like to use slope-intercept form. Okay, so let's look at example. We want to find a line, find the equation of the line through 2 points. So if you recall the previous examples, the first example we did was given the slope m and a point and 1 point. The second type of question we did was given slope and y-intercept, given m and b. And the next question we're given 2 points. And we have these 2 points given. As you can see, if you have we have a point -2, 3 somewhere here, and 4, x equals 4, y equals 5. And when we join these 2 points, we'll certainly get a straight line. So we're looking for the algebraic equation for this geometric graph. And as you can see, we only have these 2 formulas. And which one can we use? And notice that remember, to use the first formula, we must know slope m, and we also need to know a point x0 and y0. And to use the second formula, we also need to know the slope m, plus we also need to know the y-intercept. Y-intercept means that when x coordinate is 0, when x is 0, that corresponding number. So it's like the point on the y-axis and also on the line. So it's the intersection point of the line and the y-axis. So when you look at this question, neither of the information is given. We don't know the slope, but we know the slope formula. The first thing we could do is to use the slope formula. We are given 2 points. We should be able to apply the formula y2 minus y1 divided by x2 minus x1. So we can find the slope. And so the first piece of information, slope, we can easily find. But the second piece of information, we either need a point or need the special point on the y-axis. As you can see, these 2 points, 4, 5, and the other point, -2, 3, neither of them is on the y-axis. So they're not the special point. And that means we cannot use the second one directly. There is a way to use it indirectly, but it's easier just to use the first formula, because we already have, to use the first formula, we just need another piece of information, which is a point. And in fact, we got this point doesn't have to be the point on the y-axis, any point. And we're given 2 points. We can pick one of them as our point. So it doesn't matter which point we want to use. So let's see. First, let's use the formula to find the slope. Let's call this one x1, y1, call this one x2 and y2. And we can plug those numbers into the formula to find our slope. So y2, 5 minus y1, 3, x2, 4 minus x1, -2. And we simplify that, we get 1/3. So that's our slope. And we decided to use the first formula because we have a point that we can use. And in the x, notice that x0, y0 is just a notation we picked to represent a given point. You can also call, if you want, you can call it x1, y1. You can call it x2, y2. It doesn't really matter. So let's say we use x1, y1 to plug in there and to use the first formula. So the formula is y minus y1 equals m times x minus x1. So now we replacing y. Remember, y and x, they're gonna stay. But for this y1, we're gonna use 3 there. And for the slope m, we have already found it, which is 1/3. So we replace it with 1/3. And for x, we will keep it, but for x1, we're gonna plug into -2. This is our -2. And now we got our equation. And if you want to use 4 and 5, so you're going to replace x1 with 4, and you're going to replace y1 with 5. You can also do it. So you will have a looks seemingly different form, but after you simplify both, you should get the same equation, although they look different. After you distribute everything, and they will eventually look the same. So you can stop here, either this one or that one, or if you want, you can distribute and combine like terms, and you will find that you get the same answer. And that's not required, but it's optional. Here I'm going to work them out to show you that, and these two actually end up the same if we change to distribute the numbers. So first we do keep change, and that will give us y minus 3 equals 1/3 x plus 2/3, because 1/3 times x is 1/3 x, 1/3 times 2 gives a 2/3. Again, you can stop here, and this will be your answer. Take one of them as your answer. But I want this is just not part of the solution. So you can continue, and you add 3 to both sides, and you will get 2/3 plus 3. We got to equal the denominator. Let me put a plus 3 here, so 3/1, and multiply 3 here, 3 here. So we're going to get 2 plus 9, 11/3. And let's simplify this one. So we distribute that 1/3, and to get 4/3, because 1/3 times 4 is 4/3. And we add 5 to both sides. And we're going to get y on the left, and on the right, we equal the denominator, and 15 minus 4, again, it's 11/3. So as you can see, although they look different when you pick the different points, after you simplify them, they should look exactly the same. But again, you don't have to do this when you do the homework.